Hello and welcome to Azin Tech Forum. So today we are going to discuss about DNA Center security best practices, and within that we are going to see how to apply a CA sign certificate on your DNA Center, right? So what happened by default, DNA Centers comes with self-signed certificate. That means if you look at the certificate, the Kong certificate, the TLS certificate, which is presented when you try to access DNA Center, whether you are using your DNS name or IP address, it's a self-signed certificate, right? And that means it is not being trusted by many applications. It's a basic policy and all those things. These details you can see, right? It's a self-signed certificate basically. So in enterprise, this practice is not very much appreciated, and that's why in this video we will see how we can generate self-signed key, generate keys and other things, and get those keys or 509x certificate signed by internal CA, and then replace this self-signed certificate with the internally CA signed certificate. All right. So to do that, this is the link I'm going to post in description. DNA Center Security Best Practices. It is always updated quite frequently. So last update was January 28th, about a month ago. Within that, what you have to do, you have to come here, manage certificate, and read through it. This section is quite lengthy, and I highly advocate you to take some time and read through it, because there are some subtle differences which comes into picture here. All right. So security recommendation, obviously, Cisco recommend you to use a certificate signed by internal CA. By default, it uses self-signed certificate. Okay. Certificate and private key support. Two type of certificate can be imported: 509 certificate and private key certificate. We are going to use 509 in this our case. Okay. So this is a very long section, and to review this, what I have done, I have downloaded it locally, okay, and highlighted some of the section which we can review together. Okay, just for the ease of going through it. Okay. So as you can see, DNA Center uses PKI certificate management to import, store, and manage 509 certificate from your internal CA. We can import two type of certificate as we discussed here. And prior to import, you must obtain a valid 509 certificate and private key issued by your internal CA, and certificate must correspond to the private key in your possession, obviously. So if you are, you need to make sure that you have the private key and the certificate available before you upload it to DNA Center, right? And that's what we are going to do in this session. Additionally, you must replace self-signed certificate with a certificate that is signed by your internal CA for PNP functionality to work. So these are the some of the subtle details come into picture, right? If you are using PNP, or if you are using LAN automation, how you are going to choose the certificate, what details should go into certificate so that these functionalities are not broken. And that's what we are going to discuss here. Only one import X509 certificate and private key at this time. Obviously, if you try to add another one, that will be get override. Okay. And certificate chain support. Yeah, as you know, most of the time, if you are an enterprise, you may have a higher CA or root CA which sign the subordinate certificate, and then subordinate CA sign the low-level certificates, right? So DNAC support that kind of root chain certificate chain support, and what you have to do, you have to just concatenate everything and upload it to the DNA Center. This is high in simplicity. Okay. So how you can generate the certificate request? We are going to use openssl method. Okay. This is quite simple. So you have to log into your DNA Center, and when we do the demo, I'll show you everything live in the demo. So log into your DNA Center, create a directory, name it whatever is appropriate. Go to that directory. Okay. When you go to the directory, there is a prerequisite before we start generating the keys and all those things. So use this command, maglev cluster network display, and make sure that your cluster host name is set. Many times what happen, if it is a single node or even 3 node deployment, we do not bother while installation. We do not bother to set cluster host name. So make sure your cluster host name is set and it is resolvable, okay, within your network. If it is not the case, create an entry for your IP address to host name, and then within DNAC, do a maglev config update. It will result in UI, GUI, and within GUI, you can go and set your FQDN here. All right. So this is kind of like prerequisite. Okay. Now, when you are in the directory what we created, and CD change directory to that location, right? You can go there and you can say vi openssl.cnf, openssl config, and how it looks like. And then you have to, there is an example given below, and you have to change things accordingly as per your network. Okay, so let's take a quick look at the example so that we know what we are talking, right? Example open as ssl.cnf. This is applicable. This configuration is applicable for Cisco DNA Center 211 and later without LAN automation. Okay, and if you plan to do LAN automation, there are some additional requirement for that. And if you are using LAN automation, you should copy and paste this part of the configuration. Okay, and I'll talk about what is different between LAN automation and without LAN automation. So let's go. Now you know what goes into ssl.config, and you can read through this. Obviously, you have to change email address and default bits and all those things. The important is alt name section. Okay, subject alternate name. It refers to subject alternate name. Certificate configuration requirement vary depending on Cisco DNA Center version. Okay, as you can see. So basically, let me tell you what is the difference. Okay, so if you are using PNP, then what you have to do, you have to make sure that within alt name, your PNP server name is mentioned. FQDN of along with FQDN of Cisco DNA Center, you make sure that your PNP server name is also listed. Okay, that otherwise PNP functionality will be broken. Again, if you are using disaster recovery, that means you have a cold standby or warm standby cluster of data Cisco DNA Center, then what you have to do, you have to make sure that you have cluster host name set in subject alt name field. Okay, in alt name field. We do not have a DR here, so we'll not bother about that. But as you can see, this is what you have to do. You have FQDN of Cisco DNA Center main and FQDN of Cisco DNA Center recovery. All right, let's skip that. We are actually focused about getting LAN automation working. So for that, what you have to do, you must contain this alt name section must contain all IP addresses and DNS name that are used to connect to Cisco DNA Center. Okay, and as you can see here, this is the second config. And if you go to SAN field, you see we have FQDN of Cisco DNA Center. Then we have PNP server DNS name listed here to support PNP functionality, and additional IP addresses. All the IP addresses of your DNAC interfaces, various interfaces, cluster, enterprise, management, and all those. You have to list here so that LAN automation works. Because if you don't include cluster IP address in OpenSSL conf, you cannot schedule software image activation. So this functionality will also broken. So make sure if you plan to use PNP, you plan to use LAN automation. So the best is use the second example.config and list all your IP addresses here. Okay. So once you have this openssl.conf ready, what you can do, you can generate a key. Enter the following command to create a private key. Now what we are saying, we are generating, and this you have to do on DNAC itself. Okay. So you generated a private key of length 4096. After populating the field in OpenSSL config, use the private key that you created in preceding step to generate the certificate signing request. Okay, so with this key and open.ssl configuration, we are going to generate a certificate signing request, DNAC CSR in this case. Okay, once you have this, just verify that everything what you mentioned in open.ssl conf is listed here using this command. And once you see there is no typo, no fat fingers, what you can do, you can simply copy that certificate signing request and paste it to your CA. Here in this example, they are showing a Microsoft Active Directory certificate services, but for you or your enterprise, things may be different how you manage your PKI infrastructure. So just submit this signing request there, and you are going to get the certificate. Okay, it happens that you may get a chain of certificate. If that is the case, download all the certificates like local certificate, root certificate, subordinate certificate, and concatenate three of them to a single PEM file. DNAC, here we are naming it DNAC chain.pem. Okay, so now this is your certificate in the PEM format. What we are going to do next, go to the DNAC GUI, and we will replace the self-signed certificate with this new DNAC chain.pem certificate. Okay, so you can simply drag and drop. So that's about the certificate, but certificate alone is not sufficient. You have to provide the private key also, and this is the private key which we generated on DNAC. You bring that key again and drop it here on the DNA Center GUI, so that these things are complementing each other. You have certificate here and you have private key. That means it's a complete package. DNAC know how to handle this. Okay, and that's all you have to do. Click and upload and activate. Update CNA certificate. That's all. So next time when you try to log in to your DNA Center, you will see the current certificate and issue and expiry. Everything will be set as per your CA sign certificate. And that's how we are getting rid of self-signed certificate and installing a CA sign certificate in our enterprise environment. So this is what we are going to do in demo. Next, let me go to my DNAC and check the host name. And purposely, I didn't set the host name here so that I can show you what you have to do. Okay, as you can see, my cluster host name is empty, and I have to go all the way back up to here where we started, right? Sudo maglev config update and set the host name. So I'm going to do this in the background. I'll stop the video and come back and continue. All right, so I have set up the host name for my cluster, and now let's create a directory. Go to that directory. And I'm going to create a file here, openssl.cnf. As you can mention, you can see here. Okay. openssl.cnf. Okay. Now you can copy and paste the required configuration. I'm going to pause the video and paste the configuration to prepare this file. Thank you. Now we do have hostname set and openssl config available. So now let's go ahead and generate the private key. Okay. As you can see, it generated a private key for me. And now what we are going to do, we are going to sign this openssl config file using this private key. So as you can see, openssl request config, openssl conf, this is what we created with all our hostname and IP addresses, etc. And the private key we are using is csr.key, what we generated just now. and out to dnac.csr, self-sign request. Okay, you can actually go ahead and verify this. As you can see, I have csr dnac.csr available. Oh, spelling mistake here, typo. Okay, so now what I'm going to do, I'm going to take this certificate signing request, get it signed by me, my CA, and once I have this certificate file, I'm going to concatenate. So we will continue from step number 10. Okay, we are just going to concatenate that to a PEM file and simply replace the certificate. So stay tuned. Thank you. Okay, so here we are. We have submitted the certificate signing request to our CA, and I have received my CA certificate from CA. It's a hierarchical certificate. That means it is a chain certificate issuing CA, and finally signed by root CA, right? And if you're not aware about certificate in detail, I made a previous video where I'm talking about all the certificate and how it works. So I'm going to put that link in description. Now, I downloaded all these three CA sign certificate what I received in my local folder. And what we are going to do, we are going to proceed to the next step where we are going to concatenate all these three certificate files into one chain.pem. Okay, name it something, and extension should be .pem. Okay, and now the certificate is available as one. So we have the certificate available locally. Now the next task is to upload it to DNA Center. Right now, as you can see on browser screen, it is still not secure, and we will validate that by expanding certificate says invalid signed by CubeCA, which is internally signed from DNA Center. Okay, so and the same thing what we can check on browser, you can also check from your Mac terminal or any other terminal program. So watch this, what I'm going to do here. I'm going to fire a command which actually reach out to my server and present me the certificate information as of now. It's kind of like real time. Okay, so we have not uploaded the new CA sign certificate. That's why it still says cube CA and CA is false. I'm going to park this command in description so that you can use it on your own. And now what we will do, we will log into the DNA Center and replace the certificate. Okay, so this is kind of like before check, right? Okay, step 11, that's what we are going to do. So to upload the certificate, what you have to do, you have to go to system within DNA Center hamburger menu, system settings, system certificates, and there you will have an option of replace certificate. When you are replacing certificate, you need to upload two files, the newly concatenated .pem file as well as the private key which we generated sometime earlier in the video. And I forgot the step, but you can follow along the Cisco documentation. So come to settings, search for cert. You can see there are a couple of certificates options available: trust pool, PKI certificate, and certificate proxy certificate. We are primarily interested in certificate. Trust pool is like is a CA store. That means it has all valid certificates stored there. Um, but this is the place where we need to upload the certificate. Choose the method as .pem and drag and drop the file and hit upload. Okay, do the same for certificate plus private key. As you can see on the top, it says the disaster recovery, and there is a checkbox called system use system certificate for disaster recovery. We do not have a high availability cluster, so we are not going to check that box. I'm just having some trouble dragging it here. Okay, now See here, and don't forget to click upload. Unless you click upload, it's not in effect. Encryption, no, and say yes. You will be automatically logged out, okay? Because this is something which now this time I will advise you to like kill the browser and open a new browser afresh, okay? And use HTTPS version of your DNA center. As you can see, the padlock appears on my screen, and that means it is now secure. What we are going to do, run the check one more time, go to system settings, system certificate, and make sure that we have the new certificate in place. Okay, we uploaded it earlier, and now let's see what it shows there. Yes, all the new certificate signing request. Okay. Here is the trust pool. This is majorly used if DNAC is integrating with other systems, so you can import their certificate, right? Step 15, that's what we did, and our certificate exercise is complete now, okay? You can proceed with other things in this best practices, but they actually handles different use case. So please give this document a read. This is a highly recommended document, and it's been updated pretty often on monthly basis, I believe. Now let's just say, run the same certificate check from CLI as what we did previously, right? So connect to that DNAC on 443 and let's validate. So as you can see all this new certificate details. So issuer is changed from Cube CA to the new CA, and um, the part where it was saying CA false 509v3 uses is now critical, and rest of the other things for certificate information. So this is what I wanted to show you, and I hope now you feel confident and you can apply security to your DNAC cluster. Thank you.